right, mathletes. So this is practice quiz 5, which is basically question for question. What you'll see on quiz 5, and the numbers are different, but the questions are very, very similar. And so, yeah, so take good notes. Make sure you understand this. If you do, then you're going to be in good shape for the actual quiz. And you can use this. Remember, it's open notes, so you can use this as a guide on the actual quiz. So one thing that you'll see on this quiz is I'll actually tell you what formula to use. So on these first two, use a difference quotient when we're given a numerical value as an input and trying to find the derivative at a point. And then on number 3, we'll use the increment formula to find f prime of x, the derivative function, as opposed to the numerical value at a point. So in this case, the difference quotient formula, remember that is f prime of a equals the limit as x approaches a of f of x minus f of a all over x minus a. Okay, so that's what it looks like. And so remember that to get started, what we have to do is we have to find f of a, right? In this case, a is 2, right? So I'm going to rewrite this formula with 2 in there. So f prime of 2 equals a limit as x approaches 2 of f of x minus f of 2 all over x minus 2, right? So I'm just putting 2 in place of all the a's. And so now I just need to plug in 2 things, right? One is I'm going to plug in f of x. So that goes in here, right? So I'm going to put that root 4x plus 1 in there. Okay, and then the other thing we have to find is f of 2. And so f of 2 is right here. And f of 2, if we plug in 2 to this function, we get 4 times 2 plus 1 under the square root. And so that turns into 8 plus 1 is 9, so square root of 9, which equals 3, right? F of 2 is 3. So that's what we'll plug in right here. Okay, so when I rewrite this, it's going to look like the limit as x approaches 2 of the square root of 4x plus 1 minus 3 all over x minus 2. All right. Okay, so then what I'm going to do is I'm going to multiply by the conjugate because it's a radical binomial, right? And just a real quick note, if I input 2 directly here, if I do a direct substitution, I would get a 0 in the denominator, right? And I would also get a 0 in the numerator because I would get square root of 9, which is 3, and 3 minus 3 is 0, right? So this would be a 0 over 0 situation. And so that means I can algebraically manipulate this, right? So that's why we're multiplying by the conjugate here. So square root of 4x plus 1 plus 3, right? And then we do the same thing on the bottom. Okay. And so what will happen is, remember when we multiply conjugates, we get a squared minus b squared, right? And so if I square that square root, I'm just going to have 4x plus 1. And then I'll get minus 9, right? The square of 3 squared is 9. Okay. And then on the bottom, we're going to get this big mess, x minus 2 times all of this, right? And notice that I'm not distributing or foiling or anything like that. I'm just going to leave them separate, right? I'm going to leave them as separate factors. Okay. So I'm going to keep this separate from this because remember the whole point is I want to try to cancel out this x minus 2 because that's what's causing the 0 in the denominator, right? So that's what I'm trying to cancel out. Okay, so in the numerator, I can combine like terms and I get 4x minus 8, right? And so then I can factor out a 4, right? 4 is a common factor there. So on this next step, I'm going to put a 4, and then it'll be x minus 2, right? which that's looking promising because we want to cancel out the x minus 2. All right, and so now that's exactly what we'll do. These x minus 2's go away, and so we'll end up with just 4 on top, and then the square root of 4x plus 1 plus 3 on the bottom, right? And now is where I want to reintroduce the limit, okay? So you don't have to write the limit every single time all the way down, but when you get ready to directly substitute, after you cancel out whatever is causing that 0 in the denominator, that's when you want to reintroduce the limit so that now we know, okay, we can put 2 into wherever x is, right, in this case. And so what we'll get is 4 over the square root of 9, right? Let me just show the work here. So it'll be 4 times 2 plus 1 plus 3, okay? So this is going to be the square root of 9, which is 3, right? So it'll turn into 4 over 3 plus 3, which is 4 over 6. And then don't forget to reduce if you can. In this case, that'll reduce to 2/3. Okay. So that's our answer. So that's what we just found is f primed at 2, right? And so that's our final answer. Okay. All right. So remember, reintroduce the limit right before you input the value. Directly substitute 2 there, and then you don't have the limit anymore after that, right? Because you already used it up, right? It's already we already did that operation, and so now we don't have the limit on any of these future steps or subsequent steps. Okay. All right. So that's how to do that one. Good amount of work. You don't necessarily have to show every single step here. I would say like start here is a good starting place. You don't have to show these kind of plug-in steps. You can kind of go straight to the plugging everything into the formula. But these steps I do want to see, like this step here, and this step here when you reintroduce the limit. And then some of this stuff you don't have to do all that in 3 different steps. You can do it kind of in one step, and then just make sure you have a reduced answer at the end. All right, let me know if you have any questions about this one.